Friends, I welcome you to my YouTube channel MacPM. So in today's video we will solve two numerical problems based on the projectile motions. So we have already derived formulas for the projectile motions in our previous videos, and we have solved many problems also based on the projectile motion. So we have these two different type of problems based on the projectile motion. So let's solve them. First one is a projectile starting from ground hits a target on the ground located at a distance of 1000 meters after 40 seconds. What is the size of the angle theta? At what initial velocity was the projectile launched? Okay, so we have been given two values and we have to find two values, and we have another question also, but let's solve the first question first. So we will move the second question downward so that we can get some space to solve it. See, this is the projectile. This is x-axis, this is y-axis. Projectile is thrown from the origin and it falls on the ground after 1000 meter. So, okay, and time of flight, total time is given as 40 seconds. We have to find, suppose this is how the particle was thrown. So this is angle of theta. We have to find what is the size of angle theta, at what initial velocity was the projectile launched. This is in velocity v0, so we have to find v0 and we have to find theta. So let's solve. From the previous videos we have solved the formulas for this r is equal to v0 square sine 2 theta divided by g, and we have also calculated total time of flight. T is equal to 2v0 sine theta divided by g. Okay, so we can write r is equal to v0 sine 2 theta can be written as 2 sine theta cos theta divided by g. Suppose this is 1, this is 2. If we divide this equation number 2 by equation number 1, then we will get r by t is equal to v0 2 v0 sine theta cos theta divided by g, and divide it by 2v0 sine theta divided by g. This g will cancel with g, this 2 will be cancelled, this v0 also will cancelled, sine theta will also be cancelled. Sorry, this was v0 square, so this is v0 square and this is v0 square, so one v0 will be left, so r by t will be equal to v0 cos theta, this v0 and this cos theta, everything else is cancelled, and we can put values of r and t here. So r is given at 1000 meter, 1000 divided by t is given 40 seconds, this will be equal to 25. So we have v0 cos theta is equal to 25. This is equation number 3, and from equation number 1 you can see that t is equal to 2v0 sine theta divided by g. Okay, so we can put values here. T is given as 40 seconds is equal to 2v0 sine theta divided by g is 10. So this 10 will go this side. v0 sine theta is equal to 40 into 10 divided by 2. So v0 sine theta is equal to 400 divided by 2 is equal to 200. So we have equation number 4. v0 cos theta is given, V naught sin theta is given, so we can divide 4 divided by 1. Equation number 4 we can be divided by equation number 1. So we'll get V naught sin theta divided by V naught cos theta, which will be equal to 200 divided by 25. V naught will be cancelled with V naught. Tan theta is equal to 200 divided by 25 is equal to 8. So theta is tan inverse 8. If you calculate into a calculator, then you will find the value of theta. So I am calculating it. It is 82 point. Theta is equal to 82.875 degree. Now let's see what we have to calculate in the problem. What is the size of angle theta? We already calculated it, which is equal to 82 point. Theta is 82.875 degree. Now at what initial velocity was the projectile launched? We have to find initial velocity, which is V naught. So you can see that V naught sin theta, we can put the value of theta in any equation, 3 or 4, anyone. V naught sin theta is equal to 200. So we can put the value of sin theta here. So V naught sin 82.875 is equal to 200. If we calculate the value of sin 82.875, then you will get 0.99 V naught into 0.9922 is equal to 200. So if we divide, we will get V naught is equal to 200 divided by 0.9922. So we will get 200 divided by 0.9922, 201.57 meter per second. This is the value of initial velocity. So we have found the initial velocity also, and we have found the angle of projection also. Now let's move to the second problem. The trajectory of a projectile launched from the ground is given by the equation y is equal to minus 0.025 x square plus 0.5 x, where x and y are the coordinates of the projectile plane and rectangular system of axes. Find the initial velocity and the angle at which projectile is launched. So we have to find initial velocity v naught and theta is equal to angle at which projectile is launched. So you can see that if this is projectile motion, this is x-axis, this is y-axis, then this is how projectile is launched. So this is the initial velocity, this is v naught, and this is angle theta at which this is thrown. So we have to find this angle theta and this v naught. In our previous videos, you can go to our playlist projectile motion, and you can see that we have derived the equation for a standard equation, which is parabolic for the projectile motion. So you can see that standard equation from the projectile motion is y is equal to x tan theta minus g divided by 2u square cos square theta into x square. So this is the standard equation for parabolic motion, parabolic equation for the projectile motion. Now you have been given an equation also, which is y is equal to minus 0.025 x square in plus 0.5 x. So we have to write this equation in this format. So you can write y is equal to 0.5x minus 0.025 x square. So these two equations are same. So we can compare the coefficients of the x and x square. So we will find tan theta is equal to 0.5. From here 0.5 and tan theta are the coefficient of x. So we have tan theta is equal to 0.5 and we have g divided by 2u square into cos square theta is equal to 0.025. So from here tan theta is equal to 5.5. So theta is equal to tan inverse 0.5. So you can calculate from the calculator. I am calculating. Tan theta is 0.5. So theta is equal to tan inverse 0.5, which will be equal to 26.565 degree. Now we have g divided by 2u square cos square theta is equal to 0.025. You can put the values. G is 10 meter per second square, 2 into u square, or we can also write u or v naught. We have written here v naught, so you can also write v naught. 2u square cos square 26.565 is equal to 0.025. Okay, so this 10 will be divided by 2, will be get 5. So we will have 5 divided by u square into cos square 26.565. So cos 26.565 is 0.8944. So we'll have 8.8944 square. We will get 0.8 into 0.8. This is cos square 26.565 is equal to 0.025. So we have u square. U will go this side and 0.25 will come down. U square is equal to 5 divided by 0.8 into 0.025. So we will have u square is equal to 5 divided by 0.8 into 0.025 is 0.02. So if you will divide it, then you will get 250. 5 divided by 0.02 is 250. So u square is 250. So u will be equal to root 250, which will be equal to root 250, which will be equal to 15.81. This is plus minus 15.81 meter per second. Now velocity cannot be minus, so it will be plus only. So 15.81 meter per second. So this is our answer. This is u or v naught, initial velocity. So we have already found v naught and we have already found theta. These two values were asked in the question, so we have already calculated these two values. So I hope you understand how to calculate these values and how to solve this type of problem. If you have any doubt, then please ask in the comment section, and if you liked our videos, then please subscribe and share to our channel. Thanks for watching.